हमारे YouTube चैनल एक्सपीरियंस ट्यूटर में आपका स्वागत है। आज हम लोग डिस्कस करेंगे ग्रेविटेशन पार्ट 2। सबसे पहले हम डिस्कस करेंगे न्यूटन्स लॉ ऑफ यूनिवर्सल ग्रेविटेशन पार्ट 1। तो न्यूटन्स लॉ ऑफ यूनिवर्सल ग्रेविटेशन क्या है? Newton's proposed that every object in the universe attract every other object with a force that is first inversely proportional to the square of the distance between the objects, second directly proportional to the product of masses of the two objects. Newton's law of gravity इसको इस तरह से भी हम कह सकते हैं, if two objects with masses m1 and m2 are at a distance r apart, the object exerts attractive force on each other of magnitude F1 on 2 and F2 on 1, G m1 m2 upon r square। तो इसमें न्यूटन्स लॉ ऑफ ग्रेविटी में क्या है? सबसे पहले ये कहता है कि न्यूटन्स अकॉर्डिंग टू न्यूटन्स लॉ ऑफ ग्रेविटी, यदि दो masses है, two masses are separated by a distance r and masses may be m1 and m2, then F is directly proportional, F is inversely proportional to the distance between the objects. That is, F is inversely proportional to the r square and directly proportional to the product of masses of the two objects. Means F is directly proportional to m1 into m2। ठीक है, और उसको यदि हम सिंप्लीफाई करें तो F1 on 2 is equal to F2 on 1 is equal to G m1 m2 upon r square. The forces are directed along the straight line joining the two objects। ठीक है, चलिए आगे बढ़ते हैं। Newton's law of universal gravitation part 2। The gravitation force between the two particles of mass m1 and m2, इसको और विथ फिगर के साथ हमने समझाया है। तो देखिए यहाँ पे m1 और m2 दो मासेस हैं और m1 m1 m2 पर कितना फोर्स लगा रहा है और m2 m1 पे कितना फोर्स लगा रहा है ये दिया हुआ है। ठीक है, तो यहाँ पे आपको फिगर से ये समझाया गया है और इसका मैग्नीट्यूड कितना है? F इज इक्वल टू जी m1 m2 अपॉन आर स्क्वायर, जहाँ पे m1 m2 क्या है? masses of the particles और r क्या है? distance between the two particles। ठीक है, और g क्या है? यूनिवर्सल ग्रेविटेशनल कांस्टेंट। चलिए आगे बढ़ते हैं। Gravitational force and weight. Knowing g, we can calculate the size of the gravitational force. Consider two 1 kg masses that are 1 meter apart. According to Newton's law of gravity, these two masses extract an attractive gravitational force on each other of magnitude F1 on 2 and F2 on 1 is equal to G m1 m2 upon r square. Put the values of G m1 m2 and r square, you can get 6.76 into 10 to the power minus 11 Newton. This is an exponentially tiny force, especially when compared to gravitational force of the entire Earth on each masses. That is, Fg is equal to mg, which is, put the value of m and g, will get 9.8 Newton. So the above force 6.67 into 10 to the minus 11 Newton is extremely small with respect to 9.8 Newton force. ग्रेविटेशन फोर्स एंड वेट, क्या रिलेशन है वेट और ग्रेविटेशन फोर्स में? व्हेन वी फाइंड more respectable results if we calculate the force of the earth on 1 kg mass at the surface, at the earth's surface. So F earth on 1 kg is equal to GME. ME means mass of the earth, and M1 is the mass of the object, that is 1 kg, upon RE square. RE is the radius of the earth. So put the values of G, ME, M1 and RE, we get 9.8, where the distance between and the mass and the center of the earth is Earth's radius. So this is the Earth radius, and we got the value as of the force as 9.8 Newton. Now there is an example. So let us see how to solve a numerical. 3.3 kg billiard balls are placed on a table at the corners of the right angle triangle as shown in the figure. Calculate the gravitational force on the cue ball designated M1 resulting from the other two balls. Okay, fine. So M1 पे कितना फोर्स लगेगा M2 और M3 balls द्वारा, ये निकालना है. So first we calculate separately the individual forces on the cue ball due to the other two balls. Then we find the vector sum. So this is very simple. First we calculate the force on that ball, on that particular ball, by the other two balls. So F21 if we want to find, then GM2 M1 upon R21 square into J. Why J? J represents the y-axis. So we are as a unit vector we are putting J. So now put the values. Value of G, M2, M1 are R2, 21, and putting these values we got 3.75 into 10 to the power minus 11 J Newton. J is the unit vector, it just gives the direction of the force. Similarly, F31 force is equal to G M1 M3 upon M3 M1 upon R31 square I. So this force is acting towards I, that is x-axis. Put the values, you get 6.6 into 10 to the power minus 11 I Newton. Now, therefore, the net gravitational force on the cue ball is F is equal to F21 plus F31. Put put the values F21 and F31, you solve it, you'll get this value, which is 6.67 I plus 3.75 J multiplied by 10 to the power minus 11 Newton. Now, if we want to find the magnitude, then we can find it out by F is equal to under root F21 square plus F31 square is equal to, put the values of F21 and F31, you'll get it, and 7.65 into 10 to the power minus Newton is the magnitude of the force. So if you want to find the angle, tan theta is equal to, just put 3.75 upon 6.67 means F31 upon F3 F21. Okay, tan theta is equal to, and you got the value of angle theta is equal to 29.3. So this is solved. Now examples of Newton's law of gravity. So one of the good example which proves Newton's law of gravity is the dynamic of the stellar motion spanning many thousands of light years are governed by Newton's law of gravity. Examples of Newton's law of gravity, we can take more examples. For example, the inertial mass of an object, which is the mass of that appears in Newton's second law, is found by measuring the object acceleration a in response to F. Therefore, m inertial is equal to inertial mass upon F by A. Gravity plays no roles in this definition of mass. The quantities m1, m2 in natural law of gravity has been used in different ways. Masses m1 and m2 govern the strength of the gravitational attraction between the two objects. The masses used by Newton's of gravity is called gravitational mass. The gravitational mass of an object can be determined by measuring the attractive force extraction on extracted on it by another mass m, a distance run a distance r away. So m gravitation is equal to gravitation mass. Just you can write g m1 m2 by r square, and you can put the values which are known and which is not known. It will be consumed by the formula. So m gravitational, that is gravitation mass, is equal to r square fm on n upon gm. So you can go through this and you will get the details. So what is principle of equivalence? So mainly, okay, let us go through this topic. Acceleration does not enter into definition of gravitational mass. These are two different concepts of mass, yet Newton in his theory of gravity asserts that the uh, inertial mass is the second law, and the very same mass governed the strength of the gravitational attraction between the two objects. The assertion that m gravitation is equal to m inertial or inertial mass of inertial force is called the principle of equivalence. It is said that inertial mass is equivalent to gravitational mass. As in a hypothesis about nature, the principle of equivalence of subject to experimental verification or disproof many exceptionally clever experiments that look for any difference between the gravitational mass and inertial mass, and they have shown that any difference, if it exists at all, is less than 10 parts of trillion. As far as we know, gravitational mass and inertial mass are exactly the same. So you got from this paragraph, you got what is principle of equivalence. Now let us go through Kepler's law. So many years of work led Kepler to discover the orbites are not circles, as Copernicus claimed, eclipse, but ellipse. Furthermore, the speed of the planet is not constant but varies as it reports around the ellipse. Now, Kepler's law. We define Kepler's law. Planet move in elliptical orbit. Was the first law with Sun at one focus of the eclipse of ellipse. Okay. A line drawn between the Sun and a planet sweeps out equal area during the equal interval of time. The square of the planet's orbital period is proportional to the cube of the semi-major axis length. Explained with the help of a figure in the next page. So we have explained it in the in the part 1 about Kepler's law, and this is the end of our today's video.